Okay, so now let us look at another example using the direct comparison. So this is what I have. I have this series is 1 over n factorial. Okay, 1 over n factorial. Often, to use the direct comparison test, it is not very obvious to see or to construct the comparing series from the given expression. And for this example, what we can do is we can expand it, and then to see that if we can find something. Okay. So now to construct this comparing series, what we observe here is, if I expand it again into 1 over 2 plus 1 over 1 times 2 times 3 plus 1 over 1 times 2 times 3 times 4 plus 1 over 1 times 2 times 3 times 4 times 5. Okay, and then dot dot dot. And realize that, if we let the denominator to be smaller, and then the corresponding value will become larger, right? But meanwhile, when we try to construct a series, we would like to have a series that is easy to check whether it converges or diverges. Okay. So one thing I can think of here is, you see, if I want to do a comparison, is that possible? Since 1 is always there, I can omit 1. So this part is just 1 over 2 times 3. If I can change 3 into a 2, so do you realize that this number, actually 2 times 2 is smaller than 2 times 3, but the reciprocal of this is going to be less than this. I can use a similar thing to construct 1 over 2, right, times 2 times 2, and apparently this, it will be greater than this. And I can do this as 1 over 2 times 2 times 2 times 2. And you can see that all this bunch of things is going to be less than this. Okay. And of course, our series here, let me put this 1 plus 1 over 2 here. Now, guys, this inequality relationship is always true. But look at what we have here. Do you realize that this actually is a geometric series, right? Right, because this equals 1 plus 1 over 2 plus 1 over 2 squared plus 1 over 2 cubed plus 1 over 2 to the power 4, and then dot dot dot. And then if we write it out, it's going to be 1 times 1 over 2 to the power of n minus 1, right? And starting from 1 to infinity. So this is a geometric series with a equals 1, the first term, r, which is a common ratio, is 1 over 2. And from here, we can get the conclusion this geometric series actually is convergent. Okay, so since our series is less than this geometric series, and I know that my geometric series converges. So based on direct comparison test. We know that I series 1 over n factorial must convert. Okay, so that finished the problem. So to construct the comparing series for this example, it's a little bit tricky, but the idea is write it out, and then to see that if there is something we're familiar, and then to construct this inequality, and then apply the direct comparison test, and then get our conclusion. Okay, so hope you enjoyed this video, and thank you for the watching.